Welcome, everyone, to another Explainer. Today, we're taking an explosive journey deep beneath our feet to explore one of the most powerful, absolutely awe-inspiring forces in all of nature. We're getting right into the fascinating science and the incredible life cycle of volcanoes. I want you to think about something for a second. What actually happens when the Earth can no longer contain its own heat? You see, our planet is essentially this massive, incredibly pressurized vessel. And when all that intense, trapped thermal energy finally needs an escape route, well, the results are nothing short of spectacular and, frankly, pretty terrifying. Okay, let's dive into this. Part 1, inside the pressure cooker. To truly understand what's going on here, we have to travel far below the surface. Now, you probably just know a volcano as an opening in the Earth, right? But the story really begins deep, deep underground. Down there, the intense heat literally melts solid rock into this thick, glowing liquid that we call magma. Let's look at the actual mechanics of how this plays out. First, this massive pool of magma heats up, and as it does, it releases trapped gases. These gases rapidly build up just immense pressure underground. The pressure gets so incredibly intense that the magma is forcefully pushed upward. It races through the cracks in the Earth's crust until, boom, it violently bursts right out of the volcano. Which brings us to part 2, the eruption. Magma to lava. So the crucial point here is the distinction between these two things. When that molten rock is trapped underground, it's magma. But the very second it breaches the surface and hits the open air, the boundary is officially crossed. It is now lava. And this lava is dangerously hot. We're talking easily exceeding 1,000 degrees Celsius. Just to put that into perspective for you, that kind of heat makes a commercial pizza oven feel like a walk-in freezer. You absolutely, under no circumstances, want to be anywhere near this molten rock as it flows down the sides of a volcanic mountain. But you know, eruptions aren't just about glowing lava. That's just one part of it. Volcanoes also release massive columns of ash, thick dark smoke, heavy steam, and totally toxic gases super high into the sky. And depending on the exact mix of these gases, plus the specific type of magma, eruptions can range from relatively gentle, slow-moving flows to these wildly explosive, powerful blasts that can literally darken the sky for miles around. Phew. Okay. After that initial violent outburst, the eruption eventually subsides. The red-hot lava flows steadily down the slopes, and as it meets the cooler air, it begins to lose its heat. Slowly, over days, weeks, or sometimes even months, it cools down completely and hardens to form brand new solid rock. It physically reshapes the landscape forever.
Moving on to part 3, the volcano life cycle.
Now, what's really interesting about this slide is that, just like living things, these volatile forces actually have a distinct lifespan. So active volcanoes are currently erupting, or they definitely can erupt again. Dormant mountains, well, they are sleeping giants, quiet for now, but fully capable of waking up. And finally, extinct volcanoes are completely shut off from their magma supply, meaning their fiery days are permanently behind them. Let's look at part 4, destruction and creation. This brings us to a really fascinating paradox. Yes, volcanoes are undeniably dangerous, for sure. The lava, the ash, the gas, these are immediate, serious threats. But on the flip side, they're also incredible engines of creation. As that lava cools, it creates entirely new land masses, and even more importantly, the ash they eject breaks down to form incredibly rich, fertile soil. This nutrient-dense soil is absolutely essential for growing plants and supporting agriculture worldwide. So life literally blooms from the ashes.
Let's zoom out for part 5, giants of the solar system.
We've seen how they shape the soil right beneath our feet, but let's take a look at the bigger picture. Starting at home, the absolute largest volcano on Earth is Mauna Loa, over in Hawaii. It is a complete behemoth. It takes up a huge portion of the landmass there, and it stands as this towering testament to the insane thermal power trapped inside our own planet.
Mauna Loa is huge, no doubt about it. But it raises a really fun question. Is Earth actually home to the biggest volcanoes out there? Or is there something even bigger hiding out in the dark of space?
And this brilliantly illustrates just how wild our universe really is. The tallest volcano in the entire solar system isn't on Earth at all. No way. It's Olympus Mons, and it's located on Mars. This extinct Martian giant completely dwarfs anything we have here on our planet,
proving that volcanic activity is a massive force that shapes whole other worlds, not just ours. Which leads us perfectly to our final thought for this explainer. The source material sums it up beautifully here. Volcanoes can be dangerous, but they also help create new land. It's this terrifying, yet totally awe-inspiring balance. The very same forces that can melt solid rock and blacken the sky are the exact ones building the continents we stand on and fertilizing the soil that feeds us. So, the next time you look at a mountain, ask yourself, is it just a rock, or is it a sleeping giant just waiting for a planet to release its heat once more? Thanks so much for joining me, and as always, keep staying curious.